Kalau sebelum ni, okay, uh, we analyze the result, okay, for each loading test. Okay. So for example, on the previous graph, okay, we only focus on, for example, let's say this is 50 kPa. Okay. So then we plot the graph. Okay. So from the graph, we examine, okay, to get the CV value. Okay. So we have two type of method to retrieve the CV value. Okay. The first one by using the log scale, and the second one is by using the this square root of time methods. Okay. So we only can have the CV value. Okay. So in order to have the full picture, okay, for the consolidation characteristic, okay, so we need to make use all the result, okay, from all the set of testing, okay, and then we need to plot it into either a normal uh, graph or log scale graph. Okay, so we call as a data analysis stress. Uh, Actually, not stress strain. It is stress a lot. A lot. Sorry, it is a lot stress. Uh, Sorry, it is a E void ratio stress curve. Okay. So ini saya tukar kejap And show. So nanti confused. This is not the stress screen. It is a log. Is a E stress curve. Okay. Either we using this okay. Either we using normal scale, or we can use a log scale graph. Okay. Okay. So the E is represent the void ratio. Okay, saya tahu awak semua dah dengar the void ratio. Okay. While the stress or the pressure is represent the load that we apply over the area of the odometer uh, testing chamber. Okay. So the void ratio at the end of each increment periods, again the corresponding effective stress, okay, linear scale, okay, has been plotted, okay, inside the EP curve. Okay. So void ratio over pressure. Okay. So how could we determine the void ratio E? Okay. We may discuss based on Dr. Kamarudin reference book. Okay. So in that exam, in the Dr. Kamarudin reference book, okay, we may discuss, okay, on how to get the E value. Okay. So each loading, okay, each pressure providing a different value of E void ratio. Okay. So for example, for this case, okay, so the loads, okay, they apply on the what we call on the soil. Okay. So I guess it is around 12.5. Okay. So then, oh, sorry, it is around 25. Okay, 25. Okay. Then it is increased to 50, 100, 200, 400. Then this is 800, 1600, and decrease to 400 and reduce to hundreds. Okay. So this is the plot. Okay. So in order to gain the value of the MV, okay, we call it as a volume of compressibility. Okay. So we need to get the value of the AV. Okay. So the value of the AV actually is the gradients, okay, for the first curve and continue with another gradient of the second curve. Okay, so means that for the EP curve, okay, we may have two MV value. Okay, so once we already have we determine the AV value. Okay, so this AV value should be divided with 1 plus E naught. Okay, so the E naught is obtained based on the first loading pressure. Okay, so all E naught can be gained by multiplying the W times GS. Okay, so then that is the value of the E naught. Okay. Okay. The problem of the MV is not constant and only true for a certain range of stress. Okay. So for example, okay, the green tangent line, okay, show the range for the first MV, which is within 600 to is within 0 to 600 pressure. Okay, while we have pressure, okay, from 600 to 1600 to represent the value for the second MV. Okay, so it means that when we want to measure or determine the settlement, okay, so we need to identify what is the range or what is the value of the pressure. Okay, let's say the pressure is around 1000, so we may use the second MV value. Okay, because it is range between 600 to 1600. Okay, so that is the value for the MV. Okay, or the procedure to gain or to calculate the MV value. Okay, so we have another approach. Okay, where this approach is by using the log scale graph. Okay, so we plot the E value on and the pressure has been put has been plot in the log scale graph. Okay, so from there, okay, we may calculate for the CV, okay, and also the CR. Okay, so CV defined as compression's coefficient of compression, while CR is considered as recompression coefficients or coefficient of recompressions. Okay, means that we compress the soil and then we recompress it after complete the compression efforts. Okay, so for this E log P curve, okay, we have one single value of CC and also one single value of CR. Okay? So I would like to suggest, okay, it is better for us to use the CC and CR approach rather than to use the MV approach. Okay, so because in the MV we will have two different range value. Okay, so the best is to use the CC and CR because it only have one single value, and at the same time the approach for the CC and CR could cater for a different historical consolidation or historical uh, stress, okay, during the on the soil. Okay, so either we can consider normally consolidated or we can consider over consolidated case. Okay, so I will explain later on. Okay, so beside than that, okay, we can use the empirical formula, okay, to determine the CC value or CR value based on the correlation with other properties. For example, liquid limits, plasticity index, void ratio, okay, or organic contents. Okay. So this is the formula. Okay. So for example, okay, if we are not conducting the odometer test, okay, and then we want to get the CC value, okay, so we use the liquid limit value, okay, and then can estimate the CC value, okay. So that is for the CC value using the LL. Then we have another approach by using the E knots, okay. So the CC value, okay, using the E knots, okay, could be determined for all clay or an organic soil. Okay. Then we may use the organic value, okay, to determine the CC value. And also the last one is the low plasticity soil by using the void ratio value. Okay. But for me, it is better for us to carry out for the odometer test, okay, rather than we rely 100% on this empirical formula. Unless if you want to validate the result from the odometer, so we can use this formula, okay, in order to make sure that our result are within the typical value of the CC from the empirical. So empirical means that they develops the equation or the relation based on 100 or 1,000 or more than that uh, result. Okay, so that's why they can um, confident to use this formula, okay, directly without carry out for the odometer test. Okay, so there is another approach which is based on the critical state model, okay, uh, provided by Wood and Rowe, okay, to get the CC value by using the void ratio and plasticity index. Okay, so plasticity index is the difference between liquid limit and plastic limits. So for the CR, okay, CR can be estimated um, based on the CC value, and the range is between 0.05 to 0.20 from the CC value. Okay, so or we can use the critical state concept, okay, by using the PI, okay, where the CC multiply with the 1 minus A, which is A is 0.8, okay, to get the CR, or the CR can be gained from the plasticity index over 370. Okay, so that is for the CR and CC by using the empirical or the plastic limits value. Okay. Okay. So now we look on the over consolidated soil. Okay. So this over consolidated soil is related to the pre-consolidation pressure, okay, apply on the soil, okay, before we carry out for any constructions activities. Okay, so over-consolidated soil is the soil that has undergone recompressions in the odometer test. Okay, over that is under the odometer conditions. Okay, over-consolidated soil is just if the pre-consolidation pressure, they call it delta sigma C, obtained from the E log P curve based on odometer test is greater than the currently existing overburden pressure. Okay, the CC obtained from the test, okay, where the CC is uh, where the CC obtained from the test is less than CC equal to 0.009 times LL minus 10, or the Li is between 0 to 0.6. Okay, so how to measure the OCR? Okay, so we need to plot, okay, the OCR, sorry, the sigma C value, okay, and then compare with the currently existing overburden pressure, which is the sigma naught. Okay, so this existing overburden pressure, okay, we can get based from the unit weight time the height of the soil in the actual conditions. Okay, so we may go for the example later on. Okay, so this is just explanations, okay, on how to get the OCR value. Okay, so the pre-consolidation, which is the sigma C pressure, should be estimated based on E log P curve. Okay, okay. So this is example, okay, on how to determine the sigma C. Okay, so it's very important, okay, because if the sigma C over sigma naught is less than 1, okay, we can consider as a normally consolidated. Okay, or if the sigma C is equal with the sigma naught or the existing pre-consolidate existing overburden pressure, so we consider as normally consolidated as well. Okay, however, if the sigma C is greater than the sigma naught, okay, we can consider it is over consolidated. Okay, and then we may use a different formula, okay, to estimate the settlement of the soil, okay, by using the CC and CR approach. Okay, so you may, I will explain later on, okay, based on the example or calculations. Okay, okay, but first we need to know how could we determine the sigma C. Okay, saya lukis sekejap eh. Okay, so this is the procedure, okay, used by I, the point of maximum curvature on the consolidation curve, okay, which is the point of A. Okay, so we imagine here we have two curve or two yeah, we call it as a curve. Okay, the first one is here. Okay, so the second one is this kind of curve. Okay, so what is the mean of the maximums? Okay, so it means that the first curve, okay, start to change into the second curve. Okay, so we can consider the point of the changes is the maximum for the curve, for the first curve. Okay, so that is the maximum, sorry, that is the maximum for the curvature. Okay, uh, and we call as a point A. Okay, so this is the point A. Okay, then by using a ruler, so we draw a line, a horizontal line. Okay, so this is the first step. Okay, while this is the second step. Okay. Okay. Draw a line tangent to the curve at the point A. Okay. Sorry. Okay. So then we draw a line. Okay. By referring to the second line. Okay. We draw a line, a tangent line. Okay. Sorry. We draw a line. Sorry, not the that is for the fourth. Okay, for the fifth. Okay. Draw a line tangent to the curve at point A. Okay. Then we draw a tangent line. Okay. Sorry, this one. We draw a tangent line. Okay. From the on the point of A. Okay. So later on, okay, we need to know, okay, what is the angle, okay, between the procedure number 2 and the procedure number 3. Okay. Then we need to divide into 2. Okay. So they call as a bisect. Okay. So that is the procedure number 4. Okay. Then procedure number 5, we extend this second curve. Okay. Until, okay, it meets, okay, the point or the line produced from the step number 4. Okay. So the intersection between step number 4 line with the step number 5 line. Okay. So we consider as the point of B. Okay. Then from this point of B, okay, we draw a vertical line until it meet the x-axis on the log scale graph. Okay, so this x-axis, okay, is the value that represent the pre-consolidation pressure or sigma c. Okay. Okay, point A, draw a horizontal line from point A, draw a line tangent to the curve at point A, bisect the angle made by step 2 and step 3. Okay, then extend the straight line portion to the virgin compression curve up to where it meets and bisect the line obtained in step 4. The point of intersection of two lines in the approximate value of the pre-consolidation, okay, is the point A, is the pre-consolidation pressure. Okay. Boleh faham? Boleh faham tak? Hello? Senyap ni, boleh faham tak?
Boleh tak saya?
Boleh eh? Okay. Okay. Normally dalam awak punya final, okay, or your, yeah, normally in your final, so you need to plot or determine the sigma c value. Okay. So you need to make sure that you really understand on how to determine the sigma C value. Okay. Okay. So over consolidation is just if the pre-consolidation pressure obtained from the E log P curve based on odometer test is greater than currently existing overburden pressure. Okay. So kita dah tahu nilai sigma C. Okay. Then we know what will be the sigma knots. Okay. Saya repeat again. Sigma knots we can get from this gamma H. Okay. And we only consider for the clay layer only. For example, if this sand, okay, so we need to get what will be the effective overburden pressure, okay, on the clay layer. Okay, normally we only consider, okay, at the intermediate layer of clay heights. Okay, for example, if the clay is 6 meter, so the gamma H with times with 3 only, not get or not determine, not use the full length of the clay thickness. Okay. So we may learn on the example later. Okay. Okay. So then we compare the value between sigma C over sigma knots. Okay. So if greater than 1, okay, so we consider as OCR. Okay. If equal 1 or less than 1, okay, okay, like this. So we consider as normally consolidated. There are no under consolidated ratio. Okay. Okay. So that is for the sigma C. Okay. Okay. So, okay, there are some argument, okay, where the value for the uh, CC value, okay, from the odometer is not an accurate, okay, compared to the value that should obtain directly from the field. Okay. So due to the effect of sampling and preparation, the specimen in the odometer test will be slightly disturbed. Okay. So in order to get the actual value of CC, okay, so we need to draw, okay, or to estimate the CC in the actual, okay, based on the result from the odometer test as well. Okay, so kita kena gunakan result daripada E log P, okay, from the odometer. So from there we can estimate the CC actual from the E log P graph. Okay, so decrease in the slope of the compression line, okay, to show that the CC at the actual is greater than 60 measured. Okay, the field virgin compression line should be estimated based on the E log P curve. Okay, so the solid line, green solid line, okay, show the in situ curve, okay, while the what we call as the dash blue line, okay, is considered as slightly disturbed, disturbed line, which is obtained from the odometer. Okay, so this CC is calculated from the odometer, while this CC is represent the actual CC value. Okay. Okay. So how to get or how to determine the actual CC value? Okay. We look on the procedure. Okay. Produce two horizontal line at E naught and 0.42 E naught. Okay. So the E naughts based on our calculations. Okay. So we draw a horizontal line, okay, to represent the first step. Okay. So 0.42 times E naught, okay, is considered as the second step. Okay. Produce a vertical line at a pressure equal to E naught or sigma C. Okay. This line should intersect the horizontal line at E naught at point 1. Okay. So the step number 2 is step number, yeah, actually step number 3. Okay. Okay. So we already have the sigma C here. Okay. Then we extend, okay, what we call as the sigma, sorry, we extend the line, okay, for the sigma C until it meet what we call as the graph, sorry, the first E naught lines. Okay. So that is the procedure number 2. Okay. Plot compression line CC based on the odometer test. Okay. The line will intersect the horizontal line at 0.42 E naught at point 2. Okay. So then we plot a graph, okay, which is the CC, okay, from the odometer, okay, then until it meets the 0.42 E naught lines. Okay. So this intersection, okay, should be used, okay, to draw the actual CC value or the CCF, okay, by connecting the intersection point with the intersection point of sigma C and E naught lines. Okay. So nanti awak lukis garisannya ini sehinggalah dia bertemu kepada E sigma C and E naught lines. Okay. So that is for the CCF value. Okay. So a little bit higher compared to the CC value. Okay. So that is for the CCF. Okay. So now, okay, we can estimate, okay, the value, okay, for the settlement, okay, either by using the MV or the CC and CR value. Okay. Okay. Wait. Okay. So we look on the first equations, okay, to determine the settlement, okay, based on the MV value. Okay. Okay, consolidation settlement, one dimension. Okay. So we just imagine this is the thickness of the clay layer. Okay. Then we apply a load. Okay. So definitely there will be a settlement. They call as a SC. Okay. Consider a layer of settled clay. Okay. H. Due to the construction, the total vertical stress in an elemental layer of thickness dz at the depth z is increased by delta sigma. Okay, so this is delta sigma, okay, which is from the loading or from the any structure on the top of the soil. Okay, so due to this loading, so it produce an a primary consolidation, which is the SC. Okay, so similar to this one, okay, which is the E naught, okay, is the initial Watt ratio. Okay, then after we apply a load, okay, which is represent the sigma 1, so there will be a difference of delta sigma, okay, which is contribute from the additional loading. So it have a new E1 Watt ratio. Okay. Okay, so this is the existing initial stress, okay, without having any additional loads, okay, while this is the applied pressure calculated using the stress distribution, okay, which is applied on the soil, and it contribute to the delta sigma value or the increment of stress. Okay. Okay. So for the normally consolidated soil, okay. So if we are using the CC value, okay. So this is the what we call as the formula. Okay. So kita ada CC. H is the thickness. Okay. This is the thickness. Okay. It depends on the thick. It only we only use the thickness of the clay layer only. Okay. This only cater for clay layer thickness. Okay. So then we have E naught there. Okay. So this CC is gained from the odometer. Okay. Then this is the what we call as the uh, effective vertical stress. Okay. So as I told you previously, okay, the effective vertical stress we only consider at the mid or the intermediate layer of the clay. Okay, this is sand. Okay, then plus the delta sigma. Okay, this delta sigma is the load. Okay, apply on the soil layer. Okay, over the delta sigma naught. Okay, so that is for a normally consolidated. So that's why it's very important to differentiate between over consolidated and normally consolidated case. Okay, if we use MV, okay, so this is the formula for the MV. Okay, it's very straightforward, where the MV multiply with delta sigma multiply with H. Okay, so as I told you previously, the MV is depend on the range of the pressure. Okay, so you need to know what is the applied loads. Okay, on from on the top of the surface. Okay, then you may choose at you may choose at which range of the pressure for the MV value. Okay, so that is for the MV. Okay, so MV is very straightforward. Okay, but the limitation is only cover for normally consolidated soil conditions. Okay. Then we have another equation, okay, which is cover for the over consolidated soil. Okay, so for the over consolidated soil, we have two type of equation. Okay, so this is the first one, while this is the second one. Okay, so for the first one, okay, the SC, okay, is equal to CR over H over 1 plus E naught log sigma naught plus delta sigma over sigma naught. Okay, so when should we use this equation? Okay, so we use this equation, okay, when the sigma C, okay, is greater than the value of the effective stress plus delta sigma. Okay, so that is the when should we use this equation? Okay, while for the second equation, okay, we use when the sigma C is less and equal the sigma naught plus delta sigma. Okay, so that is for the sigma. Sorry, that is for the second equation. Okay. Okay. However, for the MV could not cater for this kind of problems. Okay. So that's why CC and CR approach is more comprehensive compared to the MV approach. Okay. Okay. So that is for the equation of the settlement. Okay. Later on, okay, we may discuss by using Dr. Kamaruddin reference book. Okay. So data analysis, settlement times relationship. Okay. So rate of consolidation, Terzaghi 1D consolidation theory. Okay. Assumptions, compression and flow are one-dimensional. The compressivity layer is homogeneous and saturated. Okay. So this is the assumption that we make, okay, for this 1D consolidation theory. So particle and water is incompressible. Okay, means that the water, we try to find, okay, a way, okay, to moving out, okay, during the consolidation process. Okay, Darcy law is valid. Strains due to the external load is small and within the range of elasticity. Okay, the coefficient MV and K remain constant throughout the process. There is a unique relationship independent of time between void ratio and effective stress. Okay. Okay. So okay, this is the uniform loads apply on the soil. Okay, while this is sand. Okay, so this is the water table, and the soil or the clay is fully saturated. Okay. So we just imagine this is a sand material as well. Okay. So in this case, okay, we can assume that it is a double drainage system, okay, where the thickness of the material, okay, or the D has been divided into two. Okay. Okay, this is the consolidation process, okay, where it meet the 100% of consolidation, okay, which is depends uh, on the U naught value. Okay, so the U naught is the coefficient of coefficient of consolidations. Okay. Okay, so primary consolidation, the period of consolidation where the volume change of soil is due to the drainage of water, driven by the excess pore water pressure. Okay. Where the basic equation, okay, equal to CV, where CV is equal to K over MV gamma water. Okay. So we can get the K value, the permeability, okay, once we know what is the MV and also MV value, because this is can be gained as unit weight of water, okay, 1000 10 kilonewton per meter cubes. Okay. So general solution to basic consolidation equation is given by Taylor. Okay. So this is the U, okay, where the U is the consolidation property. Okay. So it can reach up to 100%, okay, value to consider the primary consolidation is completed. Okay. Where the Z and T are non-dimensional parameter. Okay. Z is a geometry factor which is equal to Z over H, where T is the time factor, okay, in which T is equal to CV, T over H d power by 2, okay, or K is equal to MV gamma W times T over H d power by 2. Okay, so this is the time factor, okay, used to estimate uh, in terms of how long the consolidation process completed. Okay. Okay. So same with the previous one. Okay. Okay. So then U is the coefficient of consolidation or degree of consolidation. Okay. So the degree of consolidation can be expressed in the form of void ratio or change in effective stress of the change in pore water pressure. Okay. So U is equal to E1 minus E over E1 minus E final. Okay. So initially U is equal to 0 and U is equal to 100% when void ratio is equal to E final. Okay. So relationship between U and TV is represented in the form of table, graph or formula. Okay. So the degree of consolidation, okay, can be related with the TV time factor. Okay. So this is the relationship between U, P, and the depth. Okay. They call it as an isochronous curve. Okay. Okay, so this is the consolidation ratio. Okay, while this is the TV value. Okay, so because it is a symmetry. Okay, so for example, if it is completed 100%, okay, we can consider it is almost 100%. Okay, when the TV is equal to 0.9. Okay. So we can consider it is almost 100%, okay, when the TV is equal to 0.9. Okay. Okay, single drainage with versus double drainage. Okay. So for the single drainage, this is impervious. Okay. While this is pervious, where the water can go inside and outside of the sample. Okay. While for the pervious, at the bottom and at the top, okay, we consider as a double drainage. So the HD for the double drainage should be divided with 2, but HD for the single drainage should be divided with 1. So for the impervious, perhaps bedrock, okay, or what other type of material, fresh rock, we consider as a impervious layer. Okay. Okay. So this is the value, okay, for the drainage. This is the value of the percentage consolidation, okay, with the U degree of consolidation and also the TV for the double drainage. Okay. So that's why on the T90, okay, the TV is equal to 0.848, while for the T50, okay, the value of the TV is equal to 0.196. Okay, so that is the value that you should memorize, okay, for the T90 and for the T50. Okay, so if you want to get an accurate value, okay, so you may use this formula. Okay, for the U within 0 to 60, so this is the formula for the TV, while the U greater than 60, so you may use this formula, okay, to get the TV value. Okay, or this is the diagrams, okay, between the TV and also the U. Okay, the time factor be compared to the percents of consolidations. Okay. Okay. So we take a rest, okay, for 10 minutes before we continue by using Dr. Kamaruddin textbook. Okay. Any question? Stop. Okay.